Welcome back, Algebra 2 students. I hope you had a wonderful break. Today we will do 6.1 notes, evaluate nth roots, and use rational exponents. You are familiar with square roots. We know that 2 is the square root of 4, since 2 to the second power is equal to 4. This concept can be extended to other types of roots. 2 is the cube root of 8 because 2 times 2 times 2 is equal to 8. 2 is the fourth root of 16, since 2 to the fourth power equals 16. 2 is the fifth root of 32, since 2 to the fifth power equals 32. This can be extended to pretty much any root. So 2 is the nth root of a, since 2 to the nth power is equal to a. So when we're talking about exponents, we also talk about what are known as rational exponents. Rational exponents just means fractional exponents. You've never seen fraction exponents before. This is the first time you will have seen it. So on the left, you have a to the 1 over n power. So 1 over n is a fraction. You can write that as a radical. Remember, radical has a square root symbol. It's a radical symbol. And the number outside this n is known as the index. And a is just the radicand. So if n is bigger than 1 and is the index, or I'm sorry, n is greater than 1 and is the index. If there is no index, you assume it to be 2. So that's why for the square roots, you don't see a 2 out there, but that's assumed that you know that's a square root. The index becomes the denominator of the exponent. So the index is always the denominator of the exponent. In examples 1 and 2, we're going to go between radical to rational exponent notation and so on. So in example 1, if you look at A, B, C, and D, we have to just rewrite each of those problems using rational exponent notation that you see above. So remember, the number outside the radical, that's the bottom number of your fraction. So you would write this as 27 to the 1/3 power, just like that. The next one would be a to the 1/5. The next one, now this is understood because there's no number there. It's understood to be a 2 right there. So you would write that as 7 to the 5/2. As long as you know that the index is the denominator of your fraction, you're good to go. And then the last one, 3, and then 8 would be in the denominator, 2 would be in the numerator, and you don't have to worry about reducing that. You can if you want. You can say that's 3 to the 1/4, but you don't need to. All right. Rewrite using radical notation. You can go back and forth, though. So writing A and B in example 2, writing in radical notation. So remember, this is your index. So you would write the radical, or you put the 7 here. 3 is your index, and then put this in parentheses, raised to the 4th power. Okay, the next one, okay, so just figure out what number goes inside. The 4 goes inside your base, and then your index is 5, raised to the 4th power. That's what I would do. I would just identify the index. So I hope examples 1 and 2 weren't too bad. Okay. Now looking at some rules for signs, for nth root rules and signs of answers. So let's look at the nth root of a. If n is odd, there is always only one real root. It's either going to be positive or negative. If n is even, so that's great. If it's odd, you know there's only going to be one answer, positive or negative. If n is even, then you have to look at the number inside. If this number here is greater than 0, then you're going to have 2 real roots. So it's going to be plus or minus. If a is equal to 0, like you see in the second row, then you're only going to have 1 real root, and that's the answer 0, because it's always going to be 0. And if a is less than 0, there's not going to be any real roots. You get into imaginary roots. So looking at that, we can do example 3, and that'll round out the bottom of the page of our notes. So example 3, find the nth root of a. And what I would suggest doing on these is write it as a radical first, and it makes it a lot easier. So n is your index. So this is how we would write that. A is a negative number. So that applies to n being an odd number. So n is odd, it's 5. There's only going to be one answer, and it's dependent upon what a is. So here's what we're asking here. What number multiplied by itself 5 times equals negative 32? And that answer is negative 2. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is equal to negative 32. And the answer is negative because a was negative. Okay, for the next one, your index is 3. A is an even number. Well, but since n is odd, there's only going to be one answer. So what number multiplied by itself 3 times equals 64? So, oops. So, and the answer is 4. 4 times 4 times 4. Okay, the next one. Here's our first one where n is an even number. So you're going to have to look at the bottom 3 rules. If n is even, but the number a is greater than 0, you're going to have 2 answers. And I'm not going to write what number multiplied, but what number multiplied by itself 4 times equals 256. And that answer, and because n is even and the a is positive, the answer is plus or minus 4. So 4 times 4 times 4 times 4 is 256, or negative 4 times negative 4 times negative 4 times negative 4 is also 256. So there's your answer. And then lastly, n is 2. You could put the 2 out there, but remember, if it's 2, we don't ever do that. But you can. It's not going to hurt it. So if n is even, but a is negative, there are no real roots. This is imaginary. Unless I tell you what are, just assume to give the real roots, and there aren't any. That would be plus or minus 4i. Okay. Now going to our back page, we're going to evaluate each expression. So just basically answering the questions. On A, what number multiplied by itself 3 times gives us 125? And the answer is 5. What number multiplied by itself 4 times gives us 16? And remember, this is even. When that's even, you're going to look at this number, which is also greater than 0. And therefore, you're going to have 2 answers. So the number that you multiply by itself 4 times to get 16 is a positive 2 or a negative 2. So this part in parentheses is 2, and then you're going to raise it to the second power. And the other one is negative 2, and you're going to raise it to the second power. So the answer is 4, and the answer is 4. So because 2 to the second power is 4, and negative 2 to the second power is also 4. Okay, the next one, that's just 0. Because the 6th root of 0 is just 0, and 0 raised to the third power, that's just 0. Okay, and the last one. So I always tell students to, if that is confusing looking, write it in radical notation, where it's a lot simpler, because your index is 3, your base is 8, and it's raised to the second power. So this is odd, so you're going to only have one answer. And the cube root of 8 is 2. And then you're going to raise it to the second power. So the answer is 4. Okay, next one, fourth root of 16 raised to the third power. And since this is even, you look at A. This is bigger than 0. So you're going to have two answers. You're going to, well, it looks just like B. So this is 2 to the third power and negative 2 to the third power. So 2 times 2 times 2 is 8. So your two answers are 8 and negative 8. And our last one, the square root of 4 raised to the negative 5th power. This one is a hard one. So we know the square root of 4 is a positive 2 or a negative 2. So it's 2 raised to the negative 5th power and negative 2 raised to the negative 5th power. Now, if you remember, with negative exponents, we just flipped it and we put it in the denominator if it was already in the numerator. Because right now, this answer is over 1 over 1. So you're just going to flip the position. So 1 goes on the top and the 2 to the negative 5th goes on to the bottom. And when you move it, the exponent just becomes positive. The base stays the same. So that's 1 over 32. And the other one is 1 over negative 32. Those are your two answers. That was a hard one, though. All right, and we are getting close to the end. So solving each equation, we're going to solve equations like we normally do. We want to isolate and get the variable by itself. So this first one, we want to divide both sides by 5. All right, and now, just like when we had x to the second, we would take the square root of both sides. Here, we would take the cube root of both sides. Okay, and the cube root of x to the third is x because you just want one of those. And the cube root of 8 is 2. And that's your answer. 2 times 2 times 2 is 8. So there you go. And for the next one, the variable stuff is already by itself. Now, you don't go and try and multiply y minus 1 times y minus 1 times y minus 1. You'd be doing it forever. So what you want to do is take the cube root of both sides. I'm just rewriting it so it's easier looking. Okay, so that's y minus 1 equals, or about, cube root of 32 is 3.17. And what you can do is you can use a calculator or you can use your phone. And I will show you later how we can do that. And then you add 1 to both sides. So y is about 4.17. Now, if I said you couldn't use a calculator, then you could just leave it as cube root of 32 because it doesn't break down. Actually, it does break down a little further, but we're going to talk about that in a different section. Right now, you don't know that, and that's why you would be just using a calculator. Right? And our last one. So we want the variable stuff by itself. So we can divide both sides by 3 because it's outside the parentheses. So that cancels, and we have x plus 5 to the third power equals 81 divided by 3 is 27. Now you can take the third cube root of each side. And the cube root of x plus 5 to the third, you just want one of the x plus 5s. And the cube root of 27 is 3. And then subtract 5. X equals negative 2. Great. And our last problem. A study determined that the weight W in grams of coral cod in the Philippines can be approximated by the equation W equals 0.0167 times L to the third, where L is the length in centimeters. Estimate the length of the coral cod that weighs 200 grams. So this is the weight, and so this is W. So we are going to replace that W with 200 in our equation. So let's write our equation. Replace W with 200. Okay, now we can divide both sides by this 0.0167. You would want to use a calculator for this. So the left side happens to be 11,976.05. And the right side is you're left with L to the third. Okay, we just want to know what the length is. So now we can take the cube root of both sides. Just like in semester 1 when we took the square root of both sides, now we're taking the cube root or the fourth root or the fifth root, just depending on the problem. So the right side's just going to be L. And the left side, I use a calculator, and that's 22.88. And so we can answer our question. The length of the coral cod, that's 200 grams, is going to be about 22.88 centimeters. Always want to answer our questions and use units. Okay, and to kind of summarize this section, we talked about these cube roots and fourth roots and fifth roots. So these are some of the things that you should really consider memorizing. And your perfect squares, honestly, you should know all the way up to 12 to the second power. So you should all have the first 10 memorized. And even 11 times 11, 121 is pretty easy. So you should know the first 12. For the perfect cubes, you should highly consider memorizing these. And so remember, perfect cubes. So this would be 1 to the third power. This would be 2 to the third, 3 to the third, 4 to the third, 5 to the third. Most students know 5 to the third. 5 times 5 times 5 is 125. And you should really know 1, 8, and 27. A lot of you don't know what 4 times 4 times 4 is, but it is 64. And it's pretty easy to know those. But I say at least know the first 5. I mean, I put this one here, 6 to the third. I mean, I have all the way up to, I have them all memorized for the perfect cubes. Now, I won't say I know all of them, but I do know all the perfect cubes through 10 to the third power. Because and most of you do know 10 times 10 times 10 is 1,000. So this one's pretty easy also. Okay, now the perfect quads is anything to the fourth power. So 1 to any power is just going to be 1. And then that's 2 to the fourth, 3 to the fourth, 4 to the fourth. And honestly, I feel like you should know the first 4. There's not really many to memorize, but at least these 3. And then lastly, I would actually memorize those. So 1 to the fifth. 2 to the fifth is pretty easy because we do it so often. 3 to the fifth is not as easy. It's 243. Now, do you need to memorize them when you can have access to a calculator? No, but I mean, sometimes it really does help to just have some good memory skills. And those are your notes for 6.1. Have a good day.